In this video, we're going to look at a continuation of our chain rule. So now we're going to use the chain rule, but we're going to apply it to some of our trigonometric functions. Okay? So if you recall, we had two different ways we could think of our chain rule. The first was in the Leibniz notation. So if I had a function y that was in terms of u and a function u that was in terms of x, then dy dx could be found by taking dy du, meaning the derivative of y with respect to u, and multiplying by the derivative of u with respect to x. Or, if you're given a function that is a composition in terms of x, so f composed with g of x, then the derivative can be found by taking the derivative of f composed with g times the derivative of g. Okay? The second notation is the one we'll most likely use for these later examples. And so here, if I'm given a function such as 3 sine of 2x minus 3, I can see this as a composition, where my little f would be this 3 sine of x, and my little g would be 2x minus 3. Okay? So using our chain rule here, it says that f prime is going to look like the derivative of the sine function, which is going to be 3 cosine of the g times the derivative of the g, which in this case is just 2. So when we simplify, we can see that 6 cosine 2x minus 3 is going to be our derivative. Okay. If you cannot do these kind of just by looking at them or just kind of walking through like we just did, then I would recommend writing out your pieces, taking their derivatives, and then plugging in. So for example here, if my g of x is tangent of e to the x squared, I can think capital F is going to be tangent of x, capital G is going to be e to the x squared. So then when I take the derivative of tangent we know is secant squared, and the derivative of the capital G, e to the x squared, well, here we're going to have to apply a chain rule within itself. Okay? So it says I'm going to take the derivative of e to the x squared, well, e to the anything, derivative is itself. Applying the chain rule there, I need to multiply by the derivative of the exponent. Okay. So given these pieces, I can now use the chain rule by the definition. So it says I'm going to take f prime evaluated at g, so little g prime of x is going to look like the secant squared of e to the x squared, multiplied by g prime, which is 2x e to the x squared. And here when you go to simplify this, you have to be a little careful. So oftentimes I see people try to combine the e to the x squareds here, but again, you've got to remember that this first e to the x squared is inside your secant function, which means when I go to simplify this, the most I can do is bring the 2x e to the x squared out front, and then multiply that by the secant squared of e to the x squared. Okay. So there would be our derivative. Now again, just like our other derivatives, oftentimes you're going to be asked to find the tangent lines or find when the tangent lines do certain things. So in this case, let's look at y equal 2x sine of x over 3, and we want to find the line tangent to that curve at the point when x is equal to pi. Okay? So again, if you remember these types of problems, we have to do a couple of things. In order to get the tangent line, we need to get a slope and a point. And so here, for the point, we have the x value, so the first thing we're going to need to do is get the y value. So when y of pi, so when x is pi and we plug in, we're going to get 2 pi times the sine of pi over 3. Okay? And if you recall from your trig, When x is pi over 3, the y value is going to be square root 3 over 2. So here we're looking at y of pi is going to be 2 pi times the square root of 3 over 2. Simplifying, our 2's will cancel out, and we get root 3 pi. So that's the y value of the point we're going to use. Okay? So now we just need to get our slope. Okay? So here, our point we're going to need is pi, comma, root 3 pi. Now to get our slope, this again just means I'm looking at the derivative. Okay. Now here in this example we're doing a couple things to get our derivative. So first we need to use a product rule because we have an x outside of our sine function and an x inside. Okay. Then we are going to need to apply our chain rule because we have something other than just sine of x. We have a sine of x over 3. So here, using our product rule first, so I'm thinking of this as one piece and this is the second. We'll take the derivative of the first times the second plus the first times the derivative of the second. For the derivative of the second, again we need to apply the chain rule. Okay? So to apply the chain rule, we're going to take the derivative of the outside function, which is our sine. So derivative of sine is going to be cosine, evaluated at the same place we started, times the derivative of the inside. So if I look at x over 3, the derivative of that is just going to be 1/3. Okay? Again, we can clean that up some. So our y prime is going to equal 2 sine of x over 3 plus 2/3 x cosine of x over 3. Okay. That gives us our slope everywhere. To get the slope at our point, again, we're going to go back and plug in when x is pi. So y prime of pi is going to look like 2 sine of pi over 3 plus 2 pi over 3 cosine pi over 3. Okay? As we said before, sine of pi over 3 we know is root 3 over 2. Which makes cosine of pi over 3 a half. And simplifying there, we're going to get a root 3 plus pi over 3. Okay. So now that we have our point and our slope, we can plug in to get our equation of the line. So remember here, we'll use our point slope form. So y minus y1 will equal mx minus x1. Plugging in, our y1 is root 3 pi. Our slope is root 3 plus pi over 3. X minus our x value, which is pi. Okay. Simplify where we can. Again, we try to get these back into y slope intercept form. So multiplying out here, for the slope part, you're not going to want to distribute that across x. Just take and multiply it by x. For the pi piece, you do want to distribute, and that's because we still have that other term on the other side of the equation. So we'll get a root 3 pi minus a pi squared over 3. And so when we add that root 3 pi from the other side, notice those will cancel out. And so our tangent line is going to be root 3 plus pi over 3 times x minus pi squared over 3.